This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at factoring, a general strategy. And this is basically just taking the different techniques we've seen and merge them into one section. But we do go over the u-substitution here, which is new. But let's refresh our memory on our factoring. Our first method is the GCF, and I'll put an asterisk by it. We always try to do that. We look to see if they have something in common. Then our second one is grouping, and this is when you have 4 or more terms. Third one is the PSD method, and this is when it's of the form x squared plus bx plus c. Now the key part of this is you have x squared x, no number in front of your x squared. And then we have the key number, which is when it's of the form ax squared plus bx plus c. And the key part here is you have x squared x, no x, and there's a number in front of your x squared. I should say these doesn't have to be x's, they can be any variable. Then we have dots, difference two squares. This is two terms with a minus between them. Though we've seen that they don't have to exactly be terms, you just have two somethings. As long as you can write it as something squared minus something else squared. So two terms with a minus between them. We have our sixth one, which is the difference of two cubes, and this is two terms with a minus between them. And seventh one is the sum of two cubes, which is two terms with a plus between them. Now we have a u-substitution also that we'll be taking a look at. Let's look at our first problem. We got 50x to the third minus 20x squared plus 2x. Now always our first method is GCF, so we'll do that first. And they have they're all divisible by 2 and they all have an x. So I'll factor out of 2x, and that leaves us 25x squared minus 10x plus 1. Now what's inside the parentheses here is three terms, x squared x, no x, and there's a number in front of our x squared. Well, that's a key number. So do the key number. And with the key number we take the number at the beginning times the number at the end. So take 25 times 1, ignoring signs, which will give us 25. And we come up with our three columns. Write down all products give us 25. 1 times 25. 2, no. 3, no. 4, no. 5 times 5. Sum column, we add them. 1 plus 25 is 26. 2 plus 5 is 10. Difference column, we subtract them. 25 minus 1 is 24. 5 minus 5 is 0. Number we're looking for is a number in our middle term, which is 10, which is right here. So we're going to use 5 and 5. And what we do with the key number is we rewrite our middle term using those two numbers. Now, a larger number in a P column, which are both 5s here, so it doesn't matter which one you pick, but a larger number is the same sign as the middle term. Middle term's negative, so we're going to have a negative 5x. Now, the number I circled in the S column, S for same sign, so if one of the 5 is negative, the other 5 will be negative also. Then we want to use grouping on what's inside the parentheses. I look at my first group. They have a 5 and an x in common, and that gives me 5x minus 1. Second group doesn't have anything in common, but remember with GCF, anytime your first term is negative, you factor out a negative. So I factor out a negative 1. And that gives me 5x minus 1. Which gives us 2x times 5x minus 1. They both have a 5x minus 1. Remember, the goal of grouping is to get these parentheses the same. And if I factor those out, I can cross those out to see what goes in my second set of parentheses, which is 5x minus 1. Now, a lot of books will write this as 5x minus 1 squared. Like that. That's also the perfect square trinomial method, which I never went over. It's another formula that, you can do the same thing with key number and the PSD. So. Okay, let's look at our second problem. We've got 3x to the fifth minus 81 x squared y to the third. Well, first thing, GCF. Both divisible by 3, and they both have at least an x squared. So that 3's gone. I had 5 x's. I took 2 away, so it leaves me 3 x's. Minus 81 divided by 3 is 27. That x squared's gone, and we're left with y to the third. Now, two terms, though, minus string it. I think difference 2 squares, but nothing times itself will give you 27. So then I go on to difference of 2 cubes. Now remember, with the difference of 2 cubes, we're going to try to rewrite this as something to the third power minus something else to the third power. 3x squared just carries down out in front. We ask ourselves, what times itself 3 times gives us x to the third? Well, x times x times x does. For 27, that'd be 3 times 3 times 3. And y to the third, y times y times y. So we were able to write this as something to the third power minus something else to the third power. Now, what's in my first set of parentheses? It labels f for first. And what's in my last set of parentheses? L for last. And our formula for difference 2 cubes is f minus L. And f squared plus fl plus L squared. 3x squared carries down. Now everywhere I have an f, I'll plug in x. And everywhere I have an L, I'll plug in 3y. So we got x minus 3y. And then x squared plus x times 3y plus 3y squared. So we got 3x squared, x minus 3y, x squared plus 3xy. And 3y to the second power, 3y times 3y is 9y squared. And that's our answer. Let's take a look at this problem. Got 9x to the fourth minus 25. GCF, there is none. Groupings, 4 more terms, that doesn't fit. PSD and key number, both 3 terms, that doesn't fit. Dots, 2 terms to minus string it. Well, that fits. So we're going to try to write this as something squared minus something else squared. You look at each piece and ask yourself what times itself gives you that. 3 times 3 gives you 9. X squared times x squared gives you x to the fourth. And 5 times 5 gives you 25. So we were able to write as something squared minus something else squared. Difference 2 squares. We take what's inside our first set of parentheses. We add what's in our last. And we take what's inside our first. And we subtract what's in our last. And that's our answer. Grab a drink here. This next one is the u-substitution. And I don't know if I got room or not, so let me start a new page. And we got 12 x to the fourth minus 19x squared plus 5. u-substitution. We're going to, our first step, let the variable part of the middle let the variable part of the middle be u, and the variable part of the first variable part of the first be u squared. So this right here is going to be our u, and this right here will be our u squared. Doesn't include the numbers out in front of it. So this becomes 12u squared minus 19u plus 5. And step 2, factor like normal. Because at this point it's a quadratic. Well, GCF don't have any grouping. 4 more terms, that doesn't fit. PSD doesn't work because there's a number in front of our squared part. Key number. We have u squared, u, no u, and there's a number in front of our u squared. With key number, we take the number at the beginning times the number at the end. So I'll take 12 times 5, ignoring signs, which would give us 60. So we've got 1 times 60, 2 times 30, write down all products, give us 60. 3 times 20, 4 times 15, 5 times 12, 6 times 10. Add them. 1 plus 60 is 61, 2 plus 30 is 32, 3 plus 20 is 23, 4 plus 15 is 19, 5 plus 12 is 17, 6 plus 10 is 16. Subtract them. 60 minus 1 is 59, 30 minus 2 is 28, 20 minus 3 is 17, 15 minus 4 is 11, 12 minus 5 is 7, 10 minus 6 is 4. Number we're looking for is a number on our middle term, which is 19. Which is right here, which means I'm going to use 4 and 15. And we rewrite our middle term using those two numbers. The larger number in our P column that we're using, which is a 15, will always be the same size as the middle term, which was negative. The number I circled is in the S column, S for same sign, so if the 15 is negative, the 4 will be negative. And then I want to do factor by grouping. First group has a 3u in common, and that gives us 4u minus 5. Second group doesn't have anything in common, but the first term is negative, so I factor out negative 1, and that gives us 4u minus 5. Our goal is to get this parentheses same as that, which it is, so I'll factor out a 4u minus 5 now. And you can cross out the 4u minus 5 to see what goes in your second set of parentheses, which is 3u minus 1. Step 3. Plug u equals blank back in and simplify. Well, up here, remember we said u is equal to x squared. So every problem will be different in this. In this particular problem, we said u is equal to x squared. So we'll plug that back in for the u. And we got 4x squared minus 5 times 3x squared minus 1. And that's our answer. Now the u-substitution. You notice after I did the u-substitution, it put it into quadratic form, so I could use the key number method. When can you use the u-substitution? If you can take the variable part of the middle, whatever it might be, in this case it was x squared. If you can take the variable part of the middle, take it to the second power, which gives us x to the fourth, and if it gives you the variable part of the first, that's when you can use the u-substitution. I think we got another problem here dealing with it. Yeah. So let's take a look at this one. Got x to the 6 minus 9x to the third plus 20. Well, this is a u-substitution again, because if I took the variable part of the middle, which is x to the third, and raised it to the second power, that would give me x to the sixth, which is the variable part of the first. So this is the u-substitution. First step is we let the variable part of the middle be u, and variable part of the first be u squared. So this becomes u squared minus 9u plus 20. Step 2, factor like normal. Well, this is the PSD method. U squared, u, no number in front of the u squared. So we take the number at the end of 20, and we'll build a PSD table based upon it. P will list all the products, give us 20. 1 times 20, 2 times 10, 4 times 5. The S column, we add them together. 1 plus 20 is 21, 2 plus 10 is 12, 4 plus 5 is 9. Difference column, we subtract them. 20 minus 1 is 19, 10 minus 2 is 8, 5 minus 4 is 1. The number we're looking for is always a number in our middle term, which is 9, so we're going to use 4 and 5. Now our larger number in the P column that we're using, which is the 5, is always going to be the same sign as the middle term, which was negative. The number I circled is in the S column, S for same sign, so if that one's negative, then the other one has to be negative. Step 3. Plug your u equals back in at this point. We said u is equal to x to the third, so we'll put x to the third in for the u. So we got x to the third minus 4 times x to the third minus 5. And that's our answer. Next one's a u-substitution also. So let's take a look at it. So we got m squared n squared minus 7mn plus 12. Now if I take the variable part of the middle, which is mn, if I raise it to the second power, when I want to do that, it gives me m squared n squared, which is the variable part of the first. That's when you can use the u-substitution. So first step, let the variable part of the middle be u, variable part of the first be u squared. So this becomes u squared minus 7u plus 12. Now step 2, we want to factor like normal. This is a PSD method. U squared, u, there's no number in front of the u squared. With PSD, take number at the end, which is a 12, ignoring signs. If it was negative 12, we'd still just take 12, and come up with our 3 columns. P column, write down all products, give us 12. 1 times 12, 2 times 6, 3 times 4. The S column, we add them together. 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. Difference column, we subtract them, smaller from larger. 12 minus 1 is 11, 6 minus 2 is 4, 4 minus 3 is 1. Always the number we're looking for is a number in our middle term, which is 7, which is right here, which means we're going to use 3 and 4. So I got u, 3 and 4. Larger number in the P column, which is the 4, is always going to be the same sign as the middle term, which is negative. Number I circled in the S column, S for same signs, which means they're both positive, both negative. Since this one is negative, then this one has to be negative. Step 3, plug u equals blank back in and simplify. Well, here in this problem we said u is equal to mn. So we'll plug in mn for the u, and we got mn minus 3 times mn minus 4. And that's our answer. And I think next 2, I believe, are still u-substitutions. So let me start a new page. And we got 7x minus 1 squared minus 10 times 7x minus 1 plus 16. If we could take the variable part of the middle, and that's excluding a 10 out in front, the variable part of the middle, which is 7x minus 1, if you can take it to the second power and it gives you the variable part of the first, which it does, then you can use the u-substitution. So that's what we're going to be doing here. Okay, first step. Let the variable part of the middle be u, and variable part of the first be u squared. So this becomes u squared minus 10u plus 16. Step 2, factor like normal. Well, this is PSD. U squared, u, no u, and there's no number in front of the u squared. So we'll take our number at the end, 16, and come up with our 3 columns. All products give us 16. We got 1 times 16, 2 times 8, 4 times 4. Add them together. 1 plus 16 is 17, 2 plus 8 is 10, 4 plus 4 is 8. Difference column, subtract them, smaller from larger. 16 minus 1 is 15, 8 minus 2 is 6, 4 minus 4 is 0. Number we're looking for is a 10, which is right here, which means we're going to use 2 and 8. Our larger number in the P column, which is the 8, is always going to be the same sign as the middle term, which is negative. Number I circles in the S column, S for same sign, so if this one's negative, this one has to be negative. Step 3, plug u equals blank back in and simplify. Here we said u is equal to 7x minus 1, so we'll replace the u with 7x minus 1. And we can do a little bit of simplifying here. Negative 1, negative 2 is negative 3. And negative 1, negative 8 is negative 9. And that would be our answer. Oh, one more. How many number 7s do am I writing down here? Oh, I got 2 number 6s. Obviously can't count. Uno, dos. W to the 6th minus 29 W to the 3rd plus 54. Okay, u-substitution again. We can take the variable part of the middle, which is W to the 3rd, raise it to the 2nd power, and again, when you raise an exponent to another exponent, you multiply them together. 3 times 2 is 6. And that gave us the variable part of the first. That's when you can do the u-substitution. Step 1. Let the variable part of the middle be u, variable part of the first be u squared. So this becomes u squared minus u squared minus 29u plus 54. Step 2. Factor like normal. This is the PSD form. U squared, u, no number in front of the u squared. So we'll take our number at the end, 54, and we'll come up with our 3 columns for the PSD method. Write down all products give you 54. 1 times 54, 2 times 27, 3 times something, 18. 4, no, 5, no, 6 times 9. Add them. 1 plus 54 is 55. 2 plus 27 is 29. 3 plus 18 is 21. 6 plus 9 is 15. Subtract them. Smaller from larger. 54 minus 1 is 53. 27 minus 2 is 25. 18 minus 3 is 15. 9 minus 6 is 3. Always the number we're looking for is the number in our middle term, which is 29, which is right here. So we're going to use 2 and 27. Larger number, which is 27, is always the same sign as the middle term, which is negative. Number I circled in the S column, yet again. S for same signs, so they both have to be positive, or both negative. Well, this one's negative, so this one will be negative. Step 3. Plug u equals blank back in. In this case, we said u is equal to w to the 3rd. So we're going to get w to the 3rd minus 2. And w to the 3rd minus 27. Now, the w to the 3rd minus 27, that's actually the difference of 2 cubes. Difference of 2 cubs. Let's try that again. Difference of 2 cubes. Because we got 2 terms of minusing it. And w times w times w gives you w to the 3rd, and 3 times 3 times 3 gives you 27. Let me write out what I just said. So we try to write it as something to the third power minus something else to the third power. Well, w times w times w gives you w to the third, and 3 times 3 times 3 gives you 27. I'll label this as F for what's in my first set of parentheses. I'll label this as L for what's in my last set of parentheses. And the formula for my difference two cubes is F minus L times F squared plus FL plus L squared. Now the w to the third minus 2 just keeps carrying down. It doesn't change. Now everywhere we have an F, we'll plug in W. And everywhere we have an L, we'll plug in 3. So we're going to get W minus 3, W squared plus W times 3 plus 3 squared. Which gives us W to the third minus 2 times W minus 3, and then W squared plus 3W plus 3 squared is 9. And that's our answer. And time for a new page. Okay, let's look at this one. We got negative 3y to the third minus 9y squared plus 12y plus 36. First thing we'll do is GCF. If there's nothing else, it starts with a negative. We can't have that. So I'm going to factor out a negative, and they're all divisible by 3, it looks like. So that's going to give me y to the third. Negative 9 divided by negative 3 gives us a positive 3, y squared. 12 divided by negative 3 is negative 4, y. 36 divided by negative 3 is negative 12. Now what's inside the parentheses is 4 more terms, which is grouping. So I'll group the first 2 terms together, group the last 2 terms together. The negative 3 just carries down. Looking at my first group, they have a y squared in common, and that leaves me y plus 3. Second group, they both divisible by 4. My first term's negative, so I'll factor out a negative 4, and that leaves me a y plus 3. So then they both have a y plus 3. That was our goal with groupings, get these parentheses the same, which they are. So I'll factor out the y plus 3, and you can cross out the y plus 3 to see what goes in your second set of parentheses, which is the y squared minus 4. Now 2 terms of minus between it, y times y gives you y squared, and 2 times 2 gives you 4, so that's a difference of 2 squares. So I'm going to try to write it as something squared minus something else squared. And we already said y times y gives you y squared, and 2 times 2 gives you 4. So difference 2 squares. These just keep carrying down. You take what's inside your first set of parentheses, you add what's in your last, and you take what's inside your first and you subtract what's in your last. And that's our answer. Let's take a look at this one. And we'll start down here. I think this involves a u-substitution at some point. I'm trying to remember. My memory is poor. 75 x to the fifth plus 363 x to the third minus 60x. Well, first thing is definitely GCF. What's the largest number divides into all of those? They're all divisible by 3. So I'm going to factor out a 3 and an x. 75 divided by 3 gives us 25 x to the fourth plus 121 x squared minus 20 minus 20. Okay. Now what's inside the parentheses here? We're going to use the u-substitution. Let the variable part of the middle be u, variable part of the first be u squared. So this becomes 3x times 25u squared plus 121u minus 20. This would now be the key number. With the key number, we take the number at the beginning times the number at the end. So I take 25 times 20, and we ignore signs, which gives us 500. Well, that's kind of big, isn't it? All the products give us 500. 1 times 500, 2 times 250, 3, no, 4 times something. 1, 10, 2, 125? Yeah, 125. And actually, I see 125 minus 4 is 121. So I'm guessing that's it right there. Now I could continue on, but let's try that. So we're going to rewrite our middle term using those two numbers. Larger number, which is 125, will be the same sign as the middle term, which is positive. So I got plus 125u. The number I circled is in the difference column. D for different signs means one's positive and one's negative. If the 125 is positive, then the 4 has to be negative. Okay, and I want to factor by grouping. The first group here has a 25 and a u in common, and that leaves us u plus 5. Second group has a negative 4 in common, and that gives us u plus 5. Well, they both have a u plus 5, which is what I was shooting for, so the u plus 5 comes out, and that leaves us 25u minus 4. Well, remember with the u-substitution, we now need to plug u equals blank back in. In this problem, we said u is equal to x squared. So we'll put x squared back in for the u. So we got x squared plus 5, and we got 25 x squared minus 4. Now what's in the last set of parentheses will be the difference of two squares. Two terms with a minus string in it. So these just keep carrying down. So I'm going to try to write that as something squared minus something else squared. 5 times 5 gives you 25. X times x gives you x squared. And 2 times 2 gives you 4. So we're going to keep carrying this down. 3x, x squared plus 5. Difference two squares. We take what's inside our first set of parentheses, we add what's in our last, and we take what's inside our first and we subtract what's in our last. And that would be our answer. Now that was kind of a challenging problem. If you're seeing this and you're thinking, well, there's no way I can do college algebra, don't panic. Typically, and of course different textbooks handle this differently, but the typical college algebra book does not have anything this hard in terms of factoring. The idea on it is you learn real hard factoring in intermediate algebra, and then you get to the college algebra and you got your simpler factoring problems. They're like nothing to you. You're thinking, boy, this is just as easy as can be. I'm glad they didn't put those hard ones from intermediate algebra in there. So don't panic. Don't fill out your drop slip right now thinking I can't do this. This is what college algebra is like. And I think that was the last problem. Yeah, it was. So let me save this.